Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Your host is Tobias Macey, and today I'd like to welcome back Michel Tricot about the journey to the 1.0 launch of Airbyte and what that means for the project. So, Michel, can you start by introducing yourself for anybody who hasn't heard your previous appearance?
Yeah, of course. Thank you for having me, Tobias. So I'm Michel Tricot, and I am the co-founder and the CEO of Airbyte.
And do you remember how you first got started working in data and what it is about it that has kept you interested for so long?
I mean, I could go very back in the past and look at me as a teenager collecting DVX and websites because at the time Google was barely starting. But more professionally, started really in 2008. Yeah, working on financial data. I thought I was going to be a trader, and I ended up doing financial data, and I had a lot of fun with it. And what happened after that is I moved in the US, joined a very large, at the time, very small, became very large ad tech company. And everything related to ad tech and martech is about data and data at internet scale. And I would say that's really where I got burned the most and where I learned a lot of this principle around what does it mean to work with data, what is the process of data manufacturing. And at the end of the day, starting Airbyte in 2020 and have been having a blast since then.
And for people who are curious about Airbyte and some of the specifics and internals, I'll refer them back to the previous interview we did, and I'll link that episode in the show notes. But for somebody who is just hearing about Airbyte in this episode, if you can just give a quick overview about what it is that you're building and some of the notable milestones that you have gone through on your path to this 1.0 release.
Yeah. So we started Airbyte in 2020, and Airbyte is an open source data movement platform. You can almost think of it as the highway for getting data from point A to point B, and point A being like a place where you have siloed data, and point B being a place where you can actually extract value from data. And we started in 2020. That was the first release, the first open source release. And in 2021, we started to get more and more traction from the community up to a point where in the summer 2021, the whole team was completely frozen. We couldn't do anything. We couldn't build a product. We were just spending so much time on Slack, helping our community be successful with Airbyte. For me, I see that as the first real milestone. Like, yes, you release something, you never know if it's going to work, but this one was the real first milestone that I can remember because we really suffered a lot from it. It was fun, but it was very frustrating to not be able to build more. And in 2022, the milestone there was releasing Airbyte Cloud. So it was our first time having to really operate Airbyte. Before it was open source software, so we just put it there on GitHub and people would figure it out. Here we had to be our own customers of, hey, this is how you need to be running Airbyte at scale. And also what are all the pain points that go with it. And that was quite a journey in 2022. We like to refer to this one as really that this one was very much a painful year because everything that we did in 2021 was about moving fast, and 2022 was okay. We need to take a step back and look at what does it actually mean. 2023 would say was the connector builder. Airbyte is nothing without without connectors, because that's what allows us to connect point A and point B together. And I think in some point in 2022, I wrote down a document internally about what we call nailing the maintenance, which is how do you create a very large catalog of connectors, lots of breadth, and how do you make sure that these connectors are high quality, they are well maintained, etc., etc. And in 2023, we really built the first big building block to getting to that state. And yeah, now we're here in 2024. We have a ton of connectors, and we're launching the Airbyte 1.0 version. So very, very happy about that.
On that point of having the connectors that are available be high quality, reliable, I know that was one of the major concerns early in your design process, particularly given the state of the ecosystem around the Stitch framework or protocol. And I'm curious if you can talk to some of the lessons that you learned in those early days of evaluating the Stitch protocol, deciding that that didn't suit your needs, building the Airbyte protocol, the interfaces that you had around that. And I know you also went through a major revision of that protocol in that time frame as well, and just some of the lessons learned early in that process that helped inform the decisions that you made about what it actually means for those connectors to be reliable, what elements of that you wanted to be customizable versus which elements needed to be standardized, etc.
Yeah, of course. So when we think about building connectors and building a large scale of those, like a large number of those, the the thing to think about is you're not just building a connector. What you're building is you're building a factory where you get raw material in input and you get a high quality connector as an output. And for me, when I look at the past 2-3 years, this is what we've been building. Like the byproduct of it is we get more connectors, but what we are building is that factory to get from someone saying, hey, I need to get data from X to I have a working connector that will work for me for the long term. And to me, that's the big challenge in what we're doing is like, what does that factory looks like? And when we started in 2020, yes, there was the Stitch framework. Actually, initially, Airbyte was running with those connectors. And very, very fast, we realized that the quality was not there because it was basically up to every single human to just make sure that this connector always works. And there was no real like testing or ways to, I don't know, to be prescriptive about what is a high quality connector. And that's where we started to change things very fast. Like I think in 2021 we were already of this protocol, and we built our own. Obviously, we took some inspiration because there was still some good things there. But what we did first was when someone builds a connector, they need to encode the whole environment of what that connector needs. And in 2021, some people ask us, "Oh, why is that a Docker image?" And I say, "Yeah, because a Docker image, it doesn't matter that it's an image. What matters is that by making it an image, you have to encode what library needs to exist. Like if you need some specific SSL library installed on your system, it will be encoded somewhere and you will never forget about it." So it was a way of just making sure that a connector is completely self-contained and it can run anywhere, no matter what your environment looks like. You only need to have a way to execute Docker image, and that's all. And if you don't want Docker, it's fine. You can still read the Docker file and you know what you need. And you can, this way you're basically documenting what you need as code. And for us, that was really the first step. The next steps was very much around how we do the testing of those, like how we create, whether it's sandbox, whether it's replaying like API calls, etc., etc. And the goal here is just to create that asset of, hey, what does it mean to have a high quality connector? Well, you need to be able to run tests, you need to be able to run real tests, you need to be able to validate that the data looks like the schema you're describing, is all these things. And we've been building every single step of that process of manufacturing a connector. And today we have a ton of dashboards internally that are monitoring every single connector. We know which stream are working, which stream are low quality. We can, at that point, just invest more time in those, or someone from the community is going to look at it and just help us on fixing it. And finally, the last one was, how do we make it more like simpler to build these connectors? The theory that we have here is that we have a protocol and you can build anything with that protocol, but it's very painful. Like nobody creates a website with TCP IP. They all have a like higher level on top of that. And that's basically what we've done since the beginning, which is first very close to the protocol. Then in 2021, we had the first version of the CDK. That's when we started to have more like community adoption. Then another version of it. Then we started to have low code, then no code. And that's basically what we're doing to just minimize the amount of effort for building, but most importantly for maintaining these connectors. And that's, I think today, most of our connectors are using low code, no code, meaning that they can be maintained. It's just one or two 2 minutes. So, and that's what we want to get to. It has to be low cost.
Another aspect of the connectors and the ecosystem around them is that you have done substantial investment in simplifying that development process or the generation with the low code and no code interfaces, specifically on the source side. The destinations are still more complex, and rightly so, because of the need to be able to manage how updates are inserted into the platforms, the different types of destinations, whether it's a data lake or a database or a data warehouse. And I'm wondering if you can talk to some of the struggles or some of the challenges in simplifying the interface and simplifying the development effort for being able to generate those destination connectors and beyond just the source connectors that are a little bit more straightforward, at least in some cases. Obviously there are very complex source connectors as well, but
Yeah. So today, a lot of the destinations that we support, they have a lot of specificities. So you could load any data into like a SQL based store by just saying like insert. This is going to be very inefficient. So then you go and you start looking at like what is the most efficient way to load data into Redshift? What is the most efficient way to load data into Snowflake or BigQuery or like ClickHouse, etc., etc. And that's why like having a CDK for those like more heavy infrastructure is building an abstraction. You can do it. That's actually, we have one that is coming out with the CDK. We built the Oracle destination on that abstraction, and most of the destination are going to sorry, not Oracle, Databricks, and we're going to be able to use that abstraction for more and more destinations. So, but it's probably not going to be to the point where you can do low code, no code, because these systems, you want to take advantage, yes, of their specificities. Now, a place where I think destinations are going to become easier to build is going to be when we start addressing more like API types of destination, because those already have some kind of like generalized interface, which is it's an API and you're pushing data there. There might be some specificities, but they will be easier to encode in a low code, no code. So this is a place where, yes, we will be investing in a framework there.
another interesting aspect of both the timing of when you first launched Airbyte as well as the location in the data stack that you're targeting is that there have been numerous shifts in the past 4 years. In particular, starting in 2020, the rise and then subsequent decline or dissolution of the modern data stack, which is a term that nobody wants to really throw around anymore. And then also, maybe even more impactful, is the rise and adoption of generative AI and the need for vectorization of data for the semantic retrieval capabilities. And I'm wondering if you can talk to some of the ways that those industry trends have impacted the way that you think about the areas of focus and the capabilities that you're building into Airbyte and the requirements around what Airbyte can deliver to the end consumers.
Yeah. So, I think I can still remember the first README we had about Airbyte, which was open source ELT tool or something like that. I don't want to just pull the cover to myself, but I do believe that in 2021, we were the one who talked about data movement for the first time. Maybe that's wrong. I don't know, but I like to think that is true. And the reason we quickly moved away from just ETL and ELT and just going for data movement is we wanted to position Airbyte and to develop Airbyte in a way that is that is at the infrastructure layer, so that it's not about just pushing data into a data warehouse, although today it is one of our main use case. But we've seen people doing other things with Airbyte that were also super interesting. And that's why we wanted to just go a level lower and just look at it as data movement, which is moving data from point A to point B, provide intelligence on top of these pipes, and just make sure that data can be sent to a place of value. And for me, that's why, like, when I hear about the modern data stack, yes, I mean, we use the word a little bit. We stopped using it, as you said. But at the end of the day, what the modern data stack is is really what it's just like, how do you create an architecture and an infrastructure that helps you build like a long-term system. And today with like, people are going to continue to adopt warehouses. Like there is no question there. Like people need to provide and to compute analytics, to do dashboards, etc. Maybe we don't call it modern data stack, but at the end of the day, when they do something like that, we want to guide them on how do you future proof that. So yes, you have your warehouse. Think about your storage. Think about your compute. Think about your network, like data movement, like how you bring data into it, and then what comes after that. Like, do you need to do reverse ETL? Do you need to do dashboarding? So those are real problems that people will have. We just stop calling them modern data stack, but they will still be there. Now, on the Gen AI side, that's actually where we got a lot of pull from the community. The same way we got some pull for reverse ETL, never really got to it, but we got a lot of pull from the community. Is we provide pipes. How do we make sure that our pipes can connect to different systems than warehouses? How can they make sure they can connect to data lake? How can we make sure they can connect to vector databases or other type of destination? And for us, that's just how do we evolve how we build destination? Because sources are not going to change that much. Like you will still need to pull data from Salesforce, from HubSpot, from Postgres, from Oracle, from SAP. It's just where does it go and what kind of intermediate process do you need to put in place? So if you need to do embedding of the data, well, how do you configure Airbyte to do so? And that's things that we need to continue to develop because it's part of building pipes.
As far as the ecosystem of data movement, that is maybe the core essence of what data engineering is just moving data from one place to another so that you can use it for some process. Even just the, and I say just, maybe that's not the right word to use, but the constraining the scope to extract and load, which is a big area of focus and something that was the, you know, initial step of the modern data stack, is having that easy extract and load capability. There are a lot of complexities, both explicit as well as incidental complexity that comes out of it, a lot of edge cases, performance challenges. I'm wondering if you can talk to some of the hard-won lessons that you learned in the process of building and scaling Airbyte about the hard realities of data movement and data integration.
Yeah, the hard thing about it is the moment you depend on a system that you don't control, but that you're supposed to link these systems together, well, in a way, you're responsible when they go down. And that's really the problem. And that's why, like, people except people like Airbyte, nobody wants to do something like that. It's just crazy. Uh, and this to me is the real complexity. It's like sometimes, even if you want to create the best possible platform, sometimes you cannot create a pipe that is as good as you would want it to be. We have people who say, oh, pulling data from this API is slow. I say, yes, it's slow, but we don't have a choice. It's because it's rate limited on the other side. So you cannot go fast. But in a way, it always reflects on the tool. And now the question for us as like operator and builder of a platform is how do we train and educate people to understand that, yes, pulling data from this API is actually really hard because you have all these rate limiting things. Maybe there are some pieces of data that you cannot get out. Maybe like this particular API endpoint does not support like incremental updates. Like although the platform supports it, the source does not support it or the destination does not support it. And I think this is the real challenge when you're moving data is like you can build the most perfect platform, you're always dependent on the source. So now the only thing you can do is just educate, make the most of it. Like, when you have like rate limitings, you can say, yes, if we don't rate limits, they're going to close down your account. And it's like explaining like why we have to do these things. But I think here it's more like like educating the humans that depend on that data and just providing them like, yes, like this is actually something we did for 1.0 is this concept of checkpointing. Is sometimes it takes forever to pull data from an API. The last thing you want is something goes wrong in the middle, and boom, you have to start from the beginning. Like, this is the worst possible experience. And here, this is us having to work around the fact that it does not support incremental and just create this system of checkpointing to make sure that although the experience is not the best, it's not the worst. And this is the kind of thing we need to do as an infrastructure product is, yes, all these weird edge cases and setting the right expectations.
Over the past 4 years, as you said, you started with a very straightforward, here's the open source project, here are a bunch of connectors, let's see what happens, to now you're committing to the 1.0 release. Obviously, there have been a lot of evolutionary steps architecturally. What are the core decisions from an architectural perspective that you made early on that have proven to be most effective and most stable? And what are some of the aspects that have required the most constant change and exploration to settle on what you're now committing to as a stable 1.0 version?
Yeah. The one that I'm so happy we had made that decision in the past is running connectors as Docker images. Absolute game changer. And I know it adds a little bit of overhead, but it means that in terms of how we develop, how we think about maintenance, and that's the thing that is the most important. Like, these connectors needs to always work, etc. So for me, that was probably the best decision we've made in the past. The worst decision that we've made in the past now was, I don't know if the worst one. I think it was a good decision at the time, but we had to pay the price later. Was we did not optimize for scale at the time, and it's just for me, it's for like as a founder, is you should not optimize for something like scale until you have to hit some scale. And what we're optimizing at the beginning was very much like time to value, making sure that people can just download the software, get up and running, experience the value, and boom, it's done. But it had some implication. It means that there was some developments or some like architecture choice that were suboptimal for operating Airbyte at scale. And yeah, I think when we started to run cloud and to operate cloud, that's really when we started to hit this kind of problems. In 2023, we onboarded our largest customer on cloud. Thousands of jobs run in parallel. It broke our cloud. So nobody saw it, but we saw it and we felt it, to a point where we were having that meeting and someone was saying, hey, I think we made a bad deal here. It's going to cost us more than they're paying us. It creates fire everywhere on cloud. And we say, yeah, actually, no, we want to be able to take on this kind of volume for the price that we provide. And it actually forced us to work on like a completely new way of running connectors. Something we released, I think the first version was in December. It was still like behind feature flag, was how we can very quickly like spin up new data planes, so that if we have a customer that needs a lot more, like if we run into limitation on Google's API or like AWS APIs for Kubernetes, boom, we can spin up a new cluster and everything works magically. And that's really but that took a lot of time because the fundamentals were not there at the time in the platform. So we had to really build through, okay, we need scale. We need a lot of scale. The other one that was, and this one like got us into was we started to use dbt in our connectors directly. So when we put data into warehouses, we would just transform it using like a generated dbt script on a warehouse. And although it was very good at the beginning when the volumes of data were small, the moment we started to have more data, we started to have people complaining about like cost of running, like the normalization of Airbyte. And like the last thing we want is to incur more cost. So that was also a big change in like how we architect not just the platform, but really some of the connectors, was around like how we manage data warehouses. But initially it was a great decision because it allowed us to move very fast. But at some point we had to really focus on, okay, what does it mean to run Airbyte at scale? Like, we cannot do that. We have to be more efficient. We have to be smarter.
Some other interesting evolutions of the Airbyte platform are around the operability of it, where in the very early versions, it was you deploy it, here's a web app, you point and click, here are your connections, off to the races. And then over time, you developed more API interfaces for being able to do connections as code, triggering syncs as code, and now you also have the Airbyte interface where you can issue the web server component and do it entirely in a Python script. And I'm wondering if you can talk to some of the internal conversations and decisions that precipitated each of those decisions and the those capabilities in the platform.
Yeah, I think it was very much a maturity of the audience we were talking to. I think when we started, a lot of people were adopt. I mean, that was what happened in 2020 and 2021 is a lot of companies were just revamping their data stacks. I think COVID gave them a lot of breathing room to invest in this kind of project. And a lot of the people we were talking to at the time, they wanted to have like a very easy solution, just UI. Now, when you have an open source project like that, you don't control how people use your software. And what we started to see happening very fast was people not using Airbyte for their own personal use case, but just to create an application on top of it. And they started to hack around like our terrible API that we had at the time and just trying to operate Airbyte programmatically. And even ourselves internally, we have like we started to have more like needs for like workflow orchestration, and a UI is not sufficient. And very fast, like API became something we had to do. The piece around Airbyte is actually it really shows the power of how we designed connectors as very thin pieces of code, because you can transpose them to any systems. So and Airbyte is an example of it. Of let's get rid of the platform, all the heavy features, and let's just use the connector itself within code and just pull the data from code. But for me, it was really like a progression in terms of the maturity of the user, which was first very early BI people bringing, or data engineers bringing warehouses, wanting something very simple. And then you start having people who develop application on top of Airbyte or who have like more advanced use case with the orchestrator and things like that. And then it was, now we have application developers that are building with Airbyte, and the platform is good, but maybe it's too prescriptive for them. Like they don't want a UI, they don't want an API, they just want to have access to the data. So how do we serve this this audience? And Airbyte, I think for me, is just now we're in the software development land of people building application or people in notebook doing experimentation, and they don't have to take on like the whole platform. But when they go to production, they probably need to have the platform because it has all the bells and whistles for reliability.
Absolutely. Yeah, that's definitely a big piece of my understanding about the utility of Airbyte is that a big part of the value of the Airbyte platform is all of the state management of being able to see when the syncs ran, making sure to manage the checkpointing, the incremental state so that I don't have to rerun everything all the time. But that point of being able to quickly test out the connectors in a development environment, as you said, it brings a lot of value because you don't have to set up the entire platform just to test something out. Circling back a little bit to the LLM and generative AI application ecosystem of generating the embeddings, it's very straightforward to do that in a naive manner of just give me the text, I'll chunk it at arbitrary delimiters and just feed it through into the vector database. Now that that ecosystem has developed a bit more maturity and a bit more understanding about what are the appropriate chunking strategies, how do I associate different attributes and metadata with those vectors so that I can do things like filtering. And now that we have things like GraphRag starting to gain some attention, being able to associate those vectors with graph nodes, I'm wondering if you can talk to some of the challenges that you have of being able to understand how best to surface those concepts in Airbyte, and when it's just a matter of it doesn't make sense to do that in Airbyte because there's too much customization and application specific logic that needs to be embedded, and so you need to move that into a different layer.
Yeah, I actually think that right now we still know almost nothing. That's so, and you see that, we talk to a lot of our, like, whether they are startups or more mature companies, getting most of the time they don't use platforms right now. They work and build everything very vertically, and the reason they're doing it is the pace of innovation and development cannot be blocked by what feature a specific platform supports. And that's why you're seeing a lot of it built very vertically. I think platform will come, but we're probably 1 to 2 or 3 years out, ahead of that release. So at that point, Airbyte, if you look at it from like UI perspective, we can do the first POC. We can start like getting you to get to that like first aha moment of like understanding that you can get all that data with Airbyte into a vector store. Now the thing that we really need to figure out is, okay, how is the world going to evolve? Because chunking, maybe today we have something for chunking or for like embedding or like appending metadata that will work for some of the use cases, but it will probably never work for all, like most use cases. And that's why we have Pyabyte actually, is because today we just want to be there when people look and say, oh, I don't want to build a connector to bring data from, I don't know, Gong calls or whatnot. We just want we will just want to be there and just provide Pyabyte and then be with them as they experiment, because they don't know, we don't know what they need today. So for us, it's just about, can we create, can we be there at the entry point and learn from how they're using it, so that then we can bring this learning into the platform and make it a platform, and at some point have that as a data movement platform for this type of use cases. And that's really the path we've taken, where we try to address, to be there when they develop.
Another element of what you're building and how it exists in the ecosystem is that the competitive landscape for data movement has changed fairly substantially over that same time period, where when you started out, it was the Stitch data ecosystem was kind of the option if you wanted open source. There was a high degree of variability in the quality. There was no cohesive platform for operating those. Meltano came up to try and address that situation and help to bootstrap that community. On the commercial side, there was Fivetran, who is still one of the more notable fully commercial options. But then there have also been a number of other entrants. Most notably, I'm thinking of DLT as a very composable data movement capability. And I'm wondering how that shifting landscape helps you understand what are the needs in the ecosystem so that you know how to build and address them, as well as how to position yourself for people who are coming to this problem fresh and trying to understand what are my options, what are the differentiators, and how do I think about which tool to select to solve my problem.
Yeah, I would say that primarily, if you don't have connectors, it doesn't matter what you do. Like, that's the value you need to get. When I think about how we built Airbytes, there was like a ping pong ping on like connectors, platform connectors, where we started with a ton of connectors, but like mediocre platform. Then we invested a lot in the platform, did not invest as much in connector. And now that we have a platform that is running at high speed, high reliability, etc., now we're focusing again on connectors. Because at the end of the day, people take what the platform gives you as a given. They don't think that there is effort to be done in the platform, when this is actually a lot of the thing that we provide is, hey, you don't have to worry about data schema changes, etc., etc. So there will always be other players. At the end of the day, is people will pick another platform if the connectors are not the right quality. that's gonna be the thing, because and now that we have dominant player on like fully commercial and Airbyte on open source, yes, other player can come, but at the end of the day, people will make the choice based on the connectors that are available. Now there is a question around use cases, and I think the thing we're looking to address with Airbyte is how do we address use cases where it's more sophisticated use cases than pushing data. Like, it's a sophisticated use case, but more like downstream on warehouses. Here the sophistication comes from what kind of pre-processing you need to do on your data, the fact that you're not using a warehouse to process your data, like, and Pyabyte is here to just do this first discovery. And I think we have a strong community, lot of lot of connectors and a lot of use cases that are addressed today. So
Absolutely. And also, as you look across the entire data landscape, it's definitely not a zero sum game. There are still so many people who are just writing bespoke code, spending all of their time just on maintaining those different point to point connections that if they choose any of the tools, then it's a win for the whole ecosystem.
yes, exactly. And yeah, honestly, like that's also, I would say that's the power of open source, is preventing build by providing. I mean, I'm a lazy engineer. Most engineers are a little bit lazy, not in the bad sense, but they just want to not have to build the thing that, yeah, they don't want to build, and they're going to find open source. So the question here is, do they start adopting Airbyte, or do they start adopting something else? And I think today a lot of it is coming from Airbyte. But yes, we have to be very ready and provide like very strong, like, I don't want platform, I just want the connectors, because I'm building something that no platform can do today. And that's why like having our connectors as code in a code use case is very important.
Now, we've talked a lot about the history, the journey that you've been on. We've touched a few times on the fact that you're gearing up for this 1.0 release. When you do commit to a 1.0 version, there is a signaling of a certain degree of stability and commitment to the way things are right now, and the fact that you're not going to drastically change anything. And I'm wondering if you could talk to the decision process, the discussions, the confidence building that you've done both internally and the community that makes you feel that you're ready for that 1.0 version, and what that 1.0 version is intended to signal.
Yeah, we had a lot of conversation internally about when should we do 1.0. At some point we were even talking about that in 2021. That would have been a huge mistake. The thing about 1.0 is, it's really about, we have hit a milestone in terms of the technology. Now, technology is not a milestone by itself, is it has to be proven. It has to be proven by the type of workload that we are running, the type of feedback that we are getting. And like today, we believe that the platform we have is the foundation, or like the ramp for like even more data movement use cases. And that's what we wanted 1.0 to be. And the proof points that we wanted to have was, do we have more than a certain number of like enterprise users, whether they are paid users or whether they are open source users? And we got to this one. We actually hit that number earlier this year, probably. I think it was in April or something like that. But that was something we wanted to see, is like critical data analytics pipeline being handled with Airbyte with a certain amount of scale. The other piece was around the connector quality, because as I told you, we had this ping pong between connectors versus platform versus connector. And for us, it was, do we feel good about the process, the manufacturing process that we have in place for connector? And today we do. Like our ability to bring in more contribution from the community, our ability to react when a connector has an issue, our ability to just maintain that connector over time. I think today we've hit the number we wanted. And yeah, and after that it's just diversity of workload. We wanted to have, yes, the click click the UI. We wanted to have the programmatic with API. We wanted to have more of the CI/CD with Terraform, and we wanted to have Airbyte for people who are building on top of data connectors. But that was really what we wanted to get with 1.0.
And as you have been gearing up to that 1.0 launch, what has that meant in terms of the requirements that you have around new connectors being adopted, the requirements around existing connectors and their ongoing maintenance, the commitment to which connectors you are going to continue to support, which ones may still phase out and be deprecated,
Mm-hmm.
and the commitments to the community engagement and what they can expect from Airbyte going forward?
Yeah. So I think here we need to make the distinction with regard to connector between sources and destinations. Destinations, our goal here is like the moment we start building a destination ourselves, like as Airbyte, this is something that we'll continue to maintain because we've also made the choice of we see a lot of a lot of users and enterprises asking for that particular destination. At that point, it also becomes something that we charge for. So the moment they are like Airbyte maintained, they will be there for like probably ever. I'm sure there will be some exception, but that's the thing. Now, in terms of like community or like marketplace connectors, we at the source level, what we've done is we've deprecated a few of those in the past, and it was more about us like reinvesting into high quality connectors and making sure that as we build that engine, we also simplify the work for ourselves so people can still take it. But right now, in order to make that connector fit with the systems we're building, it's too much of a lift and it would require a full rewrite to be compatible with the level of quality we want. So at that point, we just deprecated them. Some people are actually taking them and just reshaping and putting them back. But for us, that was a one-time thing that we did, this thing of deprecation. It was more about, hey, this is all the learning we've had. These connectors that were built in 2021, we don't want to maintain them. And nobody in the community is doing it. So we're just going to remove them because they reflect badly on the platform and people who are using Airbyte. So we just remove them. But now it's going to be very different. We're also going to we're pushing more of sort of the metric that we look at internally around like connector quality and connector reliability. So these are now all available on our documentation. So that's also the thing we want to do with 1.0 is providing the right expectation for how is that connector behaving, how is it working, and making it easier, much easier to modify and to maintain. And that's to me the big thing about 1.0 is like we're not gonna remove connectors, we're just going to provide the right tools to make them better, and we're also providing the good visibility into the quality. I'm not sure it fully answers your question though.
No, I think that you did a good job addressing it. I was mainly just trying to get at what are the changes that people can expect around Airbyte from the community side, as well as the commitments that you're making with this 1.0 release, and
Yeah,
any substantial changes that need to be made ahead of that release to put you in a good position going forward.
yeah. The other thing we've done is we part of the system that we're building. There is also like how do we manage community contribution. I have a graph. And at some point, it was showing like how fast do we reply to PRs, and there was a moment where it was not good. Now we got it down to maybe like a day or two, but that's part of like making the process much stronger. And our goal is to just, especially for connectors, like how can we get that faster into the main line. And that's part of building that process, building that factory for connectors.
Another interesting decision that you made early on that it seems like has paid dividends is that you are keeping all of the connector definitions from the source code perspective in a mono repo. So all of the connectors, all of the platform is all in, well, actually now it's in two repositories, but all of the connectors at least are in one repository versus being spread around GitHub and having to be recollected via some website, etc. As you move towards this 1.0 release, is that something that you intend to continue with? And what are your thoughts around the possibility or viability of having some sort of kind of community discovery platform for people who are building other connectors out of band of the Airbyte repository, or any support that you want to have about maybe third-party connector libraries?
Yeah, actually, we do have some. There is a company that has been building connector by themselves, and they host them on their own repo. So the thing that we're releasing also with 1.0 is this concept of connector marketplace. And connector marketplace can be both for community members, but also for like vendors who want to build their own connector. The thing that we would like to, but this is a place where also we're going to listen to what people are telling us. Ideally, most of the low code connectors should live on the Airbyte repo. And the reason we think it's a pretty low lift is that one, now we can very quickly review this type of PR, but also there is no security concerns on these connectors because they are low code. So we control the execution framework of these connectors. It's just a YAML file that gets executed. Putting connectors on other repo, it's a place where either I mean, would we put them on the platform right away? I don't know, because at some point, like, we're dealing with data, and we want to make sure that it's not just the quality, it's also the security of these connectors. And we want to make sure that everything that we run behind the scene to validate that the connector is not doing something crazy, like, we want that to run before it runs onto the Airbyte platform. But people can already do it. They can already build connectors on repos. It's just we want to vet the connectors, because I mean, I've worked with data since 2008. Like, the amount of like data is a key asset that every companies have. Very privacy centric sometimes. We have to make sure that this data is always safe, and that's what we guarantee basically with. I mean, that's what we guarantee with having that on Airbyte. They go through our security processes and reviews.
As you have been building Airbyte, growing the company, growing the platform and the ecosystem, what are some of the most interesting or innovative or unexpected ways that you've seen the technology applied?
Yeah, the the first one is one we discovered in 2022. Was people just built a Redis destinations, and they were just using Airbyte to do cache warm up. And I was just, yeah, that's a cool use case. I love it. uh, it's just, it's this kind of thing where you don't have control. You're just giving like a knife and scissor to people, and a piece like, or like hammer and wood, and they just build something that you never thought about. The other thing, and this one became a product, was this powered by Airbyte thing. Initially, we're just thinking of Airbyte as, hey, you're just using it to push data into your warehouse, and people started to build application on top of it. It's just, oh yeah, that's a cool use case. Never thought of that. And it became we kept seeing people asking for, hey, how can I build on top of Airbyte? How can I build on top of Airbyte? And that's when we released the first version of the API, so that people don't have to click on buttons and fill form. But that's, I would say, were two very interesting ones, because one led to a product, the other one just nice, very very smart. And we have a few others, but I don't know if we want to cover all of them.
And in your own experience of going through this journey, building this platform, building this business, what are the most interesting or unexpected or challenging lessons that you've learned?
Yeah. First one was when we started Airbyte, someone gave us two advice actually. One was, don't optimize for scale, optimize for time to value. The second one was, you will never know who's using your software. Well, we followed the first advice, which was around scale. We did not invest in scale initially. That was very cool. At the beginning, became a big boulder that we had to push forward at the end, but now we're there. The one around not knowing our users, the fact that we had Slack very early on, the fact that sometimes like very early on in the UI we're asking for, hey, where what do you do, where are you from, etc. Like having this ability to know the customer or the user, whether it's on cloud or on open source, that was just it was possible. Like people were willing to help us by giving us like information like that, but it just gave us like a direct line to people. And especially early on, like now we still do it, but maybe like not at such a large scale, but very early on, every time we were thinking about, oh, should we build X or Y, we just go on Slack, or we would go and send a newsletter, like put that in newsletter, and within 30 minutes, 1 hour, boom, everyone was just telling us we prefer X or we prefer Y. So in terms of like product development and where you focus your team, invaluable. Now, I would say that the thing that are hard is building open source is hard because you don't like, especially for infrastructure, is you don't control who is using your software. Meaning that you will have people who face issues and they will not be successful using Airbyte. And as a product builder, it pains me to be in that situation where I know that someone cannot be successful with Airbyte. And yeah, you have to live with that, which is some people will not be successful with it. But it's also because you cannot control with downloading. And you cannot say, oh yeah, your use case is probably not a good fit for Airbyte. And I think that's the place where, especially as we're building open source, like how do we want to widen the net or the spectrum of users that we want to be able to make successful? That's really the challenge.
And on that note, what are the cases where Airbyte is the wrong choice and somebody should either build something custom or use some other technology that's off the shelf?
You know what? I would have had an answer for you a few months ago, but now we released by Airbyte. So I would say there is probably okay, maybe for pre 1.0, yes, there is one around like streaming type of use cases. Like we don't do those. Now it's planned for post 1.0, but otherwise with Pyrebyte now you can do whatever you want. So you have access to all the catalog of connectors on code, and you can add all the logic you want on top of it. So yeah, probably that would probably be the former gap and the no gap today.
And looking forward to that post 1.0 world, you hinted at streaming. What are some of the other capabilities that you have planned for the future of Airbyte once you have moved past this 1.0 milestone? You've committed to stability in the platform and the interfaces, and so you have a more stable target to build off of and move fast on.
Yeah, I, for us, it's going to be very much on like operational use cases. I think we've been very focused on analytics, data warehouse use cases. All the AI use cases are pulling us into the direction of operational use cases. And reverse ETL is an operational use cases. Streaming, in my head, only makes sense for operational use cases where it's not a human making decision, but a machine making decision. So that's going to be a big focus for us post 1.0 is like, how do we address things that are not analytics, but are also like operation driven? The other one is we have a large roadmap around like enterprise connectors. We're starting to release some of those, but we have a long roadmap and we're working with our enterprise customers to build them. So we want to release them in the next few months. Speed is going to be a big deal. I think we have some low hanging fruit that we want to make faster. You will see we've made a few changes in the past few months. Like speed has gone up quite significantly, but I think we can still do a 10 times, like a times 10 somewhere. So that's, I'm very excited about. Like data needs to move as fast as possible. We can never be a bottleneck.
We didn't really touch on it throughout this conversation, but I'll also say thank you for all of the work that you and your company have done on the outreach perspective of providing a lot of high quality blog posts, conducting the state of data engineering surveys year over year to help collect some of that information, and just all of the investment that you're putting back out into the community as well. With that being said, are there any other aspects of the work that you've been doing on Airbyte, the 1.0 launch, the future that you're building towards that we didn't discuss yet that you'd like to cover before we close out the show?
No, but I think we're going to have some new unstructured data is going to be unleashed. And I'm very curious to see like how that's going to pan out. We have some theory, but it's basically you're saying that now 80% of the data that was very, very expensive to leverage is going to be unleashed. I'm looking forward to that world. And want to make sure that we're positioning Airbyte also in that field, because we're data geeks. We want to push and get more data through the pipes.
All right. Well, for anybody who wants to keep in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I think the biggest gap is what do we do with unstructured data? Like it's going to be a lot of things around like the security, the privacy of that data, because it's not as easy as doing a regex on something. So to me, that's the big deal today.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you and your team have been doing on Airbyte. Congratulations on the 1.0 milestone. I've been using Airbyte for several years now, so appreciate all of the value that has provided for my own work. So thank you again for all of the time and energy you folks are putting into that, and I hope you enjoy the rest of your day.
Thank you, Tobias.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.